My name is Samantha Sifleet. I am an environmental data scientist at RTI. RTI is a local nonprofit research institution here in RTP. Today I'm going to talk to you about developing Shiny applications using Leaflet in R. And I had this whole presentation totally laid out on Friday, and I saw a great presentation by Bill Hargrove yesterday, and it made me rethink this. So we are going to talk about the technology, but I'm going to really get into the example, the projects that I've used this on, because I think that's going to be a lot more interesting. So a quick overview. I'm going to talk a little bit about R, talk a little bit about Leaflet, introduce what Shiny is, the basics, development, deployment, and then I have these 3 example apps. One is a Wake County Food Violations Explorer. It's really in the preliminary stages, so I think that's a great place for us to start. I've developed a toxics and climate change tool, and then the final tool, the Water Quality Portal Data Discovery tool, is a really big, complex app, and that's where we're going to wrap up. So to start, R is an open source statistical programming language. It's based on S. The real part about R that I try to sell to people is the packages. R is great because of all the people who've contributed to these individual packages that can be highly specialized or not, but that's where the power is that there's so many people out there working in it and developing unique packages and problem solving for research, that's where the strength really lies. So that's kind of the main point I wanted to make there. So using R has kind of starting to overtake SAS, but it's really great for data display and complex statistical analysis. And again, that's because so many people have kind of built these little components that are specialized to their field and really extend it. So a lot of people, this is my little plug for RStudio, a lot of people work in R at the console, the command line, and that's great. RStudio is a free IDE, and it is fantastic. So the few little demos I'm going to show you today, it's free, not trying to sell you something, but I worked at the command line for years and years and years and years, and I finally made the move over, and I want to bring everyone with me because it will really change your life. Okay, so there's some fantastic packages. If you're new to R or maybe you've been using R, I just wanted to throw them out there. Data.table really lets you kind of access your data as if it were in a database, even though it's an object in R. ggplot2 is fantastic for kind of intuitively letting you create these really pretty graphics that go way beyond the base graphing package in R. And these charts that I've shown here, a lot of people will tell you never to loop in R, that there's looping functions, and there are, and that's great for data cleaning. You can loop in R. These right here, both of these, I've generated 7,000 of them using a loop on a virtual machine. So looping in R, people say, no, not totally feasible. You can generate high-quality graphics really, really fast, and they can be responsive. Those loops will let you be responsive and checking your data, making those axes what you need. And then dplyr and tidyr, I use dplyr a little bit, but this is a lot of people who do data wrangling. Those are 2 other packages that they love. So great place to start if you're totally new. Leaflet, I think everybody in this room has kind of a concept of what Leaflet is. It's an open source JavaScript library for mobile-friendly interactive maps. Really gets that interactive component that ggplot or mapping in R might not have. So Leaflet for R is a package that was built by RStudio. And the R functions are actually going to generate the JavaScript and HTML for the Leaflet maps. And you can install as always, the fully documented version or go with the development version, which is really cutting edge right now. You can get some really cool features if you install it off of GitHub. I'm going to do a really quick example here because, like I said, I want to get to the good stuff. So in R, you always want to load that library. And to generate a Leaflet map, this is the code. I mean, seriously, this is what's going to give you that interactive web map. And here it is. got my pop-up, it's zooming, it's interactive. That's simple, okay? So again, you want to add to it, you can use pipes. So this is where my little plug for RStudio comes in. If I need documentation, it is right there, right there. What do I need? What are the functions? What are the parameters? To add to that map, you can pipe and just add another marker. Here we are at FOSS4G. Here's RTI. We're still interactive. Very, very quick, rapid deployment, getting that leaflet map up and running. And I had examples to add shapefiles and add GeoJSON and style. You can do all of that. It's very, very simple. There's tons of tutorials. They're going to show you better than I in this limited time. So let's move on. Shiny. What is Shiny? Shiny is a web application framework for R built by RStudio, and it's based on Twitter Bootstrap. So it's responsive. Shiny functions, just like the leaflet functions, are going to translate R code into HTML, CSS, and JavaScript for you. There's tons of tutorials, tons of examples. Again, the end of this presentation has just a slide full of links. I've loaded it up to the web. Go crazy. It is a very simple framework, okay? Every app has two files, a UI and a server. That's it. I'm going to do a quick demo here. Okay, so for this one, I made it a little bit more complex because you want to see the statistical power of R. Like, that's what makes this special, is that you're adding that web framework on top of this really powerful statistical programming language. So here, I have a function that's going to generate my UI. I'm going to load my library. I'm defining a color palette. I'm defining my UI. Okay, again, with RStudio, here's my UI. If I want to look at it, I can. And then I'm going to define that server function. And I'll come back to this in a second. And then we're just going to run it with a single call. Okay, so here we have a nice visualization of k-means clustering. So, you know, that, again, nice, strong, powerful statistical procedure. But we're allowing the user to now further explore the data. We can change the cluster count. So we've made the inputs to that complex statistical function interactive, and we've created this wonderfully user-friendly display for exploring the data and kind of providing the non-programming population with a way to dig into those powerful statistical procedures. Okay, so again, we'll get into this a little bit more, but here we're running, you know, taking the selected data, that input, those input are passing through, filtering the data, and then we can run that procedure, and then we have a render function that's actually going to generate the plot. So very simple, very straightforward. And this example is up on the web at RStudio. It's an example of the k-means clustering. You can look in this code. You can play with it. Okay. So that is Shiny. Okay, so then I showed you Leaflet. We can, a couple lines of code. We can generate an interactive map in R. How are we going to share that? Well, Shiny provides a wonderful framework. You know, we can kind of structure this user interface, create reactive inputs that are being rendered in the outputs. So the next step would be to add a Leaflet map to a Shiny app. Okay, so again, we're going to load the libraries. We're going to set a directory. And I'm just going to run it. I'm going to let it go, and we're going to walk through the code. Now open in the browser. All right, so quickly, through the code. Everything, we've loaded in our libraries. We've told it where the data is. We're going to read in some GeoJSON, and then we're going to do a little styling here because we want it to look pretty. These are just Wake County parks I'm going to show you. Here we're putting a button up there. We've got a main panel that's going to hold our map. And then this is exactly the same code we had from before. We're just adding the markers, but we're also going to add that GeoJSON. There's a little bit of reactive observation functions in here. So when that button's clicked, what we're going to see is going to change, but let's take a look at it. Okay, so here we have our 2 points. I changed the base map. We can zoom. We have all the features of an interactive map, and we can add and remove those parks. So very, very simple, quick to deploy, easy to share mapping application. Okay. So Shiny deployment. Shiny apps can be deployed via the web. There's a Shiny server that you can have. We have a client that has an internal Shiny server. We can build apps. They'll deploy it, and anybody inside their firewall can go, and it's a great way to look at data. So they can just kind of click through, change graphs, look at different data. You can also use a Shiny Apps.io, get a free cloud account. That's what I have. There are limitations on the free cloud account. You have so many hours on the server per month. And you can have, if you want more hours, you can pay. The other option, so the first 2 apps I'm going to show you, I have deployed as web apps, so you can follow the links and you can go and look at them. If they stop working, it means I ran out of hours. Or you can develop a desktop tool, and so you can package up the app and actually just create a launch script, and somebody's going to run that. Somebody could run that from command line R, they just, without ever having to type a single thing. So that's the last app I'm going to show you. Okay, so the Wake County Food Violations Explorer. Let me just go refresh it. So hosting and deployment, you can learn all about that here. RStudio, great, great resources. We're going to refresh this. Okay. So this is a very simple app. It's still in the development stages. They currently don't have funding, and I'm not expecting funding to hit again until June. So this was a great app to kind of show you how the process of development works. But also, this is kind of the primo case study of where I think Shiny fits best. And the reason there is because we are developing this with Wake County data, working with the Wake County Department of Health, working with the State Department of Health. And the whole goal here is to add more data into this tool so that we want to build a model of food violations and the adoption of the new food code. So we do a lot of food safety work at RTI, and we're going to start adding, we want to pull in some socioeconomic variables from the census, maybe at the census block group or level. We want to bring in other data, and we want to allow our collaborators at UNC and with the state and the county to easily be able to look at how we're kind of, what's the distribution of these data? Do we have multicollinearity going on? What's appropriate for us to kind of construct this model? And that's where I see Shiny being a great, great resource and kind of technological selection, because you have all that statistical power behind it, and it's very easy to share this. I would not recommend doing large geoprocessing tasks in R and Shiny. That is not where I see this fitting. This is much more of a communication tool, a collaboration tool. That's where I see it fitting the best. But here, let's take a quick peek at the code. So this is all my data loaded in. Again, I've got a server file. I've got a UI file. And in my server file, you can see I'm doing the same things. I'm loading those libraries. Whoa. Come back. There we go. I think I stepped on it. So here, we're still running. That guy. So again, here what's going on is we're loading in all these data, and we're going to bind that with a shape file. So right here, the map data is reactive. As I was changing the selection in the drop-down, you were seeing basically different columns of data in a shape file, and that's all happening here. R creates what's called a large spatial polygons data frame, and that's what's storing that information. And it's just calling it's very similar to, again, you're working with shape files. So yeah, so that's that first example. We're going to move on to the climate change app. Okay, I'm going to reload that. Let's pull the files in so we can take a quick look. Okay. So this app pulls in 10 years of toxic release information from the EPA. So any source that stored and leaked any toxic chemical that's on their list is in here. Let's load the data into the map. Again, this is starting to be, this is a more complex app, but it's still only a couple hundred lines of code. You know, and it is, again, deployed to the web for easy sharing. It's got, you know, more information here, so kind of walks the users through what this data is, why I built it. Basically, there was a data viz challenge on looking at toxics and climate change, and so this is my response to that.
Did you win?
I did not win. It was not, I didn't get enough to the impacts. It was more, this is more of a data viz tool. So let's give it a second. Oh, it was loading. All right, so this one has a progress bar. I'm going to run it from the code. There it goes. Okay, it has a progress bar, which we all know are just kind of faking the user out while it loads the data. This is pulling shapefile data. I will say shapefile data takes forever in R. Okay, so here we go. This guy is totally movable, so I'm just going to put him over there for now. But what happens here is this is responsive based on zoom level. So when you get counties, and then I'm going to give you some summary statistics on the counties on the facilities there. When you keep going in, you're going to get to point specific. And these are actually companies, and it's going to tell you the earliest release date, the latest release date, and what chemicals those companies have released. And then when you zoom out, those are going to disappear. Then, additionally, we're going to load in some NOAA web services to serve up sea level rise. So let's look at Chesapeake Bay. Boop. And we can drag up sea level based on NOAA. I believe these are just bathtub models, but NOAA serves them up. So, again, not a lot of work on my end to do this. But when you get in close, again, you can start to see facilities versus sea level rise, which was the goal. And then I started adding in some of the heat projections, the future climate scenarios. So I have days of extreme heat. I just picked 2030 because it seems close enough that I can conceptualize it. And so days of extreme heat over 90F. Again, these are grumpy shape files. Everything converted to GeoJSON would be my recommendation on how to go. Again, we have another layer, so we fake them out with a progress bar while it loads the shapefile again. Okay, so that is the Toxics and Climate app. Let's look at the code real quick. So again, I told you it was not fancy, and it's not. So again, here I'm really just faking them out with the progress bar. I'm saying, hey, move a little bit, take a nap, move a little bit. Here we go. So here, I mean, this, to get the sea level rise in, it's one line for each layer I want. And then I'm hiding it, and I'm using a proxy map. If you really want to do this, Leaflet proxy is a command you want to look at because you do not want to re-render your map every time. So using a proxy map where you're just kind of turning layers on and turning them back off, and that's in these hide group and show group. So when I load a layer onto a map, I'm giving it a name. I'm giving it a group name. So then all of my inputs are turning off, hiding, or showing. But I'm never re-rendering my map. That's about it on this one. Okay, so the big one I really want to share, I'm not running anything, is the desktop tool. Okay, so EPA and the USGS have this huge data warehouse. It is called the Water Quality Portal, and it combines two older databases, NWIS, which was USGS, and STURAT. And this is where water quality data states there's funding kind of tied to submitting to this database. So everybody does put their data there because it kind of keeps the money flowing. So it serves up data via web services. But again, I'm actually going to launch it from the command line. So this is, if you don't want to deploy it to the web, you can build a little script that will run it, and they never have to write any code. Okay. Launch finish script. And it's going to launch your app. So your user, you could develop a desktop application, and there's a link in here. You can go and download all the code for this tool. We're still working on optimizing the web services, so I'm going to get the query going, and then we'll talk about the details of this one a little more. So we are going to go out to the water quality portal, and we're going to pull in all the data for Wake County from January 1, 2015. So it's building that web service query. It's going to take a second. It's just running an HTTP header request to make sure that that is a viable query. Yeah, I've got data there. Okay, import that data. So remember when I told you how great Datatable is and how wonderful R is because of all these packages? The reason this tool exists in R is because USGS had already started writing a package called data retrieval in R that was designed to go and pull data from the water quality portal. But it was still, people had to know how to write functions, they had to know how to write code. So we've kind of walked on, added on top of that. This app is much more complex, so it's constructing that. Oh, sorry, right back to the data table. So data retrieval exists. USGS wrote this package, and it's great. It goes out and it gets data. It first got data from NWIS and Storette, and then the water quality portal came. So it's got these functions. But they weren't using data.table. And data.table significantly improves processing time in R. So there are still some lags. They've pushed to their dev version, but for this release, we had to use what was pushed to CRAN and actually fully documented. So processing time should speed up with the data pulls once we move there. Again, back to the app as a whole. The server file is huge, and RStudio is starting to develop modules. It's a framework for kind of chunking out that code, and I'll walk you through I don't have a single UI file for this. I have a file for each of my tabs as we go through it. So let's take a look if our data is back. Okay, our data is back. So the thing about this database, when you kind of bribe people to put data in, they just throw it in there. And you really have no QA on this data. It's just kind of everything and anything is up there. So they wanted a tool that could give the user some control and kind of walk them through thinking about QA, QC on this data before they do anything with it. So this tab here, we allow them to decide how they want to deal with non-detections. They can set them to 0. They can set them to the limit of detection, 1/2 the limit of detection. And it's going to update the different data sets that we've prepared for them. We give them different data sets that they can look at, all the data, the non-detects, the ones that have no units, no methods, duplicates. And then we have a filtered data set, and the filtered data set is very explicitly defined here. At any point in time, they can export this data, and it's going to come with metadata. So it's going to tell them what was the URL query that they sent out, what did they get back, and what did they do with those non-detects, what QA methods did they apply. And they can run a summary. This they love. Again, fakey toolbar, or progress bar. So view data, this is what you guys all wanted to see. We're just kind of showing here how many records are returned based on the station. And here we also added in the ability to further refine the filters on the data set that they have returned. So here, I think I was going to get rid of this one and that one. And so those circles are all going to rescale and redraw based on whatever they've decided, and then they can add these back in. Okay, so if they want to drill into data at a site, When we give them a data table, they can look at the data table. They can filter it and then save it here. And we're going to generate. So here we have some interactive. This is another JavaScript library. Great, I have 10 minutes. OK. This, again, is ggplot, interactive chart. We can take stuff out. We can add stuff in. Still using high charts here. They can do whatever they want here, change the parameters that they're looking at. They can zoom. They can export. OK, so one of the things I wanted to make a quick point of before I wrap up here is the fact that you're using it within R is giving you a very straightforward framework. So your simple little R commands are generating HTML, CSS, and JavaScript for you. But because it's generating that, you still have the option to go in and say, no, I want it to actually run this bit of JavaScript rather than what that function would automatically generate. And so in here, if we look at these on the query data, my drop-downs are being generated by a web query that I've written the JavaScript for that to go out to the web, and you're actually seeing. Trying to navigate to it in the code is going to be too much, but you're seeing a list that's generated by a domain service for that value. So I'm not feeding it a CSV or telling it what it is because this database is constantly updating. But that's the flexibility that you get with this framework is if you want it to be really simple, it can be incredibly simple. I showed you like Leaflet. It's a couple lines of code. You get an interactive map. If you want it to be highly specified and unique to your needs, you can customize it by going in and editing that JavaScript. The help file on this, I actually wrote the HTML for this. It was just easier for me to write the HTML for this than to write the R functions. It gave me a little bit more control over what I was doing. So I'm going to end there and hopefully take some questions. So right now, they're all down, and there's a bunch of people from my group in EPA that are down at the Water Quality Conference in Tampa this week, and they're kind of revealing it. And you can go, it has not been pushed to GitHub. The original view here is that the code will be up on GitHub, and then we want people to be able to say, hey, in my state, I really want to look at this, and they could build another tab. Right now, I just started working on an analysis tool that will take the exports with the metadata attached, and then you'd be able to do your water quality criteria assessments. So each state has different water quality criteria, and they need to do an assessment of are my stations above or below meeting these criteria, which can vary by parameter, seasonality. But so that's the next tool that we're also hoping to develop in the same manner of being completely open source. But EBA has yet to push this to GitHub. You can go to the website in my slides, and you can pull the whole tool. You'll have all the code. But it's not, I'd really like to get it up there so if people start developing off of it, we can kind of see what's going on. Okay, yeah, so let's talk about, so the Storette tool, we have, I'm just going to open this in R. We have a script that is saying, check the version of R. If you don't have the right version of R, prompt the user to update R. Check that you have all these packages installed. If those packages aren't installed, install them. Then load Shiny, because you have to have Shiny. And then you're going to run that app and launch the browser. So this script itself exists just for the people who don't have RStudio installed, aren't comfortable writing code, even if it's one line, run app. that's what and I've also written a troubleshooting script, so if people have issues, that will go through and it will check all the packages and if they need to be updated. The problem with the troubleshooting script is if you don't have admin rights, we get live path issues. So in the next version, we're going to have a troubleshooting script for those who have admin privileges and a troubleshooting script to have for those who don't have admin privileges. And there, in the help tab, there's an email. So we have, like, if you did find a bug and the troubleshooting script did not fix it for you, we would then ask you to fill out that form and email it to us so that we can at least log the bug for the next version that's coming out. Yeah. Yes. Not yet. I do not. Yeah, I'm just kind of learning as I go. But now I'm curious. Now I'm really curious. I posted the slides. The package itself, so when you look at the slides, this link, so this is where you can go and you can pull the whole tool. But they have not pushed, EPA needs to post to EPA. The EPA funded this project. So right here, you can download the tool package itself, but it's not on GitHub. So if you want to modify it, you can. We just have no way of knowing what you're doing, and I'd love to know how it's useful or helpful to people. In the next version, I want to continue, like I want to pull all the reactives out of the server file. That server file is way too big. There's a lot of things, and I think having it up on GitHub, if people are actually using it and there are people who like to code using it and they have suggestions, I want to see that. So right now you can totally get your hands on it. Just if you have suggestions, you'd have to email them to us. It's not going to be tracked up there. So. You said you posted your slides where? On the Phos4G. Yeah. So I just did that right before this time because I was tweaking everything, and I think this went better than me just showing you random points on a map. Mm-hmm. I will definitely try to do that. I have very little control over what goes on in the Drupal environment with EPA. They're pretty strict. Okay. But yes, I would hope it would be here because that's where people are going to go for the tool. So, yeah. And there should start being a link for the analysis tool. But again, that won't be out, and I don't even think I'll be releasing a version 1 until probably the fall. So for beta, if you want to be a beta tester for the analysis tool, email me because I would love that. Yes. So that's me. I'm sorry I don't have Twitter. Well, thank you all for coming. This was a great showing.